Yes, this is your Dr. Vantara Shiva. In this video, we are going to discuss about one of the interesting questions from the chapter current electricity, and it is based on the concept of nodal analysis. Okay, let us take the question. Find the potential difference between the points A and B in volts in the circuit shown in the figure. Okay, yes. Now here A is here and B is here. Now we want to find out the potential difference between A and B. That's all. Now here we are going to use the nodal analysis. Let us see what it is. Basically, the first and foremost step in nodal analysis is we need to identify nodes. What do you mean by node? If more than two wires, meeting at a point is called that point is called node. Okay, let's consider here three wires are actually meeting here, here three, here three. It can be more than three also. Okay, three or more than three. Okay, these are the nodes in the given problem. Now what we are going to do is we are going to apply one of the basic concepts, that is nothing but conservation of charge. What is the conservation of charge means? In an isolated system, charge is always conserved. So initially if there is a net charge is 0, generally before charging a capacitor, that the net charge on a capacitor is going to be 0. That's what. So generally charge is always conserved. In the capacitor it is actually 0 initially, and finally now also it should be 0 on if it is a if you are considering isolated system. How do you consider isolated system here? Let us see. We are going to consider this one, half of the capacitors like this. Now this will become one isolated system, and now another isolated system. This is the first isolated system, and other one is this one. It looks like a separate part actually, like that. This will be like a second isolated system. Now let us take first isolated system, first one. Then let us apply net charge equal to 0 there. So what does that mean? So here Q is equal to capacitance times the potential difference, that is the charge. Alright. Now you consider each and every capacitor and on which potentials it has been, in between what potentials this capacitor has been connected. That's what you have to see here. Alright. Now let us find out the potential at each point right now. Let's consider the potential at A is VA and potential at B is VB, let us say. Okay. Now here along this path you are connected, you are coming across a 20 volts cell, and it has to be raised. Along the path potential is raising, so it is nothing but VA plus 20. Okay, and here it is grounded here, so it should be 0 volts. Along this path potential is going from, you are crossing from lower potential to higher potential. That means what potential should be raising by how much? By 20. If this is 20 volts here, and in this path you are moving along this, you are coming across a cell which is you are actually going from higher potential to lower potential. That means what potential should be dropped by how much? This much. 20 minus 10 is nothing but 10 volts. Very good. Now here you are having 10 volts here. Along this path potential should be decreased by how much? Because you are moving from higher potential to lower potential. That means potential should be reduced. So 10, and how much it should be? So it should be minus 10 volts, so that the difference between these two will be like 20 volts. Clear na? Yes. Now here the potential is VB, and in this direction if you are moving, potential should become VB, and you are moving from lower potential to higher potential. Therefore there will be potential raise, that will be like VB plus 20 here. That is all. So we have taken the potentials at each node. Okay, let us take this capacitor is connected between this and this capacitor is connected between this and this potential differences. This capacitor is connected between VA and 0. This capacitor is connected between VA and 20. Let's apply that. Let us take a 5 microfarad. I am not writing that 5 micro here. Anyway, every capacitor is having the micro in general. I am not worrying about that right now. Now 5 into, so you are starting from VA here. Your potential minus other potential, VA minus 0, and this capacitor is connected between VA and 20, that is 10 microfarad, VA minus 20 here. Next, this capacitor is connected between VA plus 20 and 20. That capacitor is actually 10 volts, 10 microfarads, sorry, 10 microfarads is connected between VA plus 20 minus 20. Alright, now this 5 microfarad is connected between VA plus 20 and minus 10. VA plus 20, and that has to be subtracted from VA plus 20. That's it, na? So this is the net charge in this isolated system, 1, and that should be equal to 0. That is what is called charge conservation. Okay, now here 5 into VA, 10 into VA, 10 into VA, 5 into VA. So 5 plus 10, 15, 15 plus 10, 25, 25 plus 5, 30. VA here 0, here 10 20s are 200. Now here this 20, that 20 gets cancelled. Now you are having minus of minus 10, so plus 10, 20 plus 20 plus 10, 30, 35s are 150 is equal to 0, 30 VA. Now minus 200 plus 150 is nothing but minus 50. Take it to other side, you get 50 here. Then this 0, that 0 gets cancelled. V potential at A is nothing but 5 by 3 volts. Isn't it clear? Yes. If it is not clear yet, let us try to apply the same thing, charge conservation, yet for the isolated system 2. So this is the second isolated system. Again, let us you have to look at the charge capacitors. This capacitor is connected between VB and minus 10. So 10 microfarad. Again, I am not considering this micro anymore. VB minus of minus. Already one minus is there, and existing minus, no, minus 10. Clear now? This 5 microfarad capacitor is connected between VB minus 10. Clear? Now this is another capacitor that is of 10 microfarad, and that is connected between VB plus 20 minus 10. VB plus 20 minus 10. Next, this 5 microfarad capacitor is connected between VB plus 20 minus 0. Alright, so that is all. That should be that the charge in an isolated system is 0. Conserved basically. Here 10 VB, 15 VB, 25 VB, 30 VB. Now minus or minus plus 10 tens are 100, minus 5 tens are 50, 20 minus 10 is nothing but 10, 10 tens are 100. Okay, next 5 20s are 100 is equal to 0. Now here 30 VB, this is a 100 plus 100 plus 100, 300 minus 50 is nothing but 250, and that will come out to be minus 250 on the other side. This 0, that 0 gets cancelled. VB is nothing but minus 25 by 3, and he is asking for VA minus VB. The potential difference between A and B. So here VA is nothing but 5 by 3 minus VB is nothing but minus 25 by 3. This minus that minus gets cancelled. So 5 by 3 plus 25 by 3 is nothing but 30 by 3. So that will be like 10 volts. Is that clear? So basically we have applied here nodal analysis, and charge is always conserved in an isolated system. That's all. These are the only two things we have applied, and and the other thing is Q is equal to C delta V. That's it, and that's equal to 0. So I hope it is clear. Thank you very much for watching. See you once again in the next video.